Okay, so today we are going to see two or three points regarding the solar radiation potential in India. So this particular diagram we saw in yesterday's lecture, it will indicate the counter map of the radiation which is received by the Indian subcontinent. So you can see here the solar radiation received by the overall Indian surface of the overall India is much greater than the average radiation received by the global or the Earth. Okay, so you can see this particular area, the all over the area of India. Okay, generally this part it will having an average radiation which is around 1462 61 kilowatt hour per meter square. Okay, so this is an average radiation received by the Indian subcontinent. So you will identify the potential to produce the electrical power by using this solar radiation, or you can also use the solar thermal applications to uh, achieve that particular power or to use that particular solar energy. So that's why we are mostly focusing on the absorbing or developing the new techniques as well as the plan to mount or to install the different PV cells, PV cells power plants, and also the thermal power plants which are based or where we can use this particular solar energy. On the right hand side, you will see this particular counter map of India or the Indian subcontinent where the photovoltaic power potential. It is showing the photovoltaic power potential, means how much power we can generate at that particular location. So here also you can see all over the across the India. If you leave the northern part of the India near to the Himalaya ranges, all over other part of the area, which is included the Deccan Plateau, then the upper some part of the UP, Bihar, etc., and also the part of the Rajasthan and Gujarat, all these things. You will see the potential is much more than the other parts of the world, and you can use that particular solar energy or the solar radiation to generate the electricity. Okay, so you can install the particular PV plant near by studying this particular maps and studying the radiation data which will observe or which will gather through the different sources. Okay, so before planning any particular solar plant or the solar applications, we must study this particular data because the performance of the particular that system, it is depends upon how much radiation is received at that particular location. Obviously, there are some local factors which will going to affect the intensity of radiation. It will be there, but before that, you must know annually how much amount of radiation, which is average radiation, will be received by that particular location, and by studying that one, you can plan to install or implement that particular solar energy power plant. Okay, or the PV power plant we can say. So this study of the radiation and the study of the data which is observed or the whatever the temperature at that particular location, all during all the seasons or during all over annual data of the radiation, it is important. Okay, and then you can plan the that particular PV plant or the thermal energy plant, etc. Now, this solar radiation and the whatever it is actually today also the most of the nearly 16% of energy electricity will be generated through the solar PV plants, where we are using the solar radiation to create to generate the electricity. Okay, so current status, if you want to see, uh, you will see this particular website of Power Ministry, where you can see the actual generation of the electricity in India, how much resource-wise generation and also the sector-wise generation. So you can see here, this is the sector-wise generation where you can see the central sector will generate nearly 24%. The state sector will generate is generating the 25% of the energy, and the private sector is largely generating the electricity or the power, which is around 50%. So that is sector wise. If we saw the installed generation capacity resources wise, which is on the 31st March 2023, you will see the variation or the different resources through which we are generating the power, and its particular percentage. Okay, so you can see particularly in the fossil fuels, mostly nearly 60% of the energy is generated through the fossil fuels by using the fossil fuels. It may be in thermal power plant, it may be in other power plant also. Okay, so you can see in fossil fuel also we are largely depends upon the coal because nearly 50% of energy, okay, nearly 50% of total energy has been generated through the coal-powered thermal power plant. So you can see that they are mostly or largely depends upon the coal, which is an again a fossil fuel. It is non-renewable type of resource, and it will impact the environment in the negative way. So we have to reduce the dependency on this coal. Also, you will see the some power, nearly 6% power is generated through the natural gas, burning of the natural gas. 0.1% is generated through the diesel power plants, etc. So these are the fossil fuels which are used to produce or generate the electricity, and those are the non-renewable type of resources. And also, it will going to affect the nature of the environment in the negative way. So, to avoid the dependency on this particular fossil fuels, we have to concentrate on the renewable type of resources. And most of the uh, uh, till now we are concentrating, we are trying to implement more and more plants or the renewable energy plants in which you can see the hydraulic energy which will contain share that is 11.3%, and the other renewable resources you can see you can see here wind energy will contain 10.2% share, then the solar energy that we are studying now, that is contains 16.1%, and other type of energy. So you can see in the renewable energy, most of the renewable energy or whatever the energy is generated through the renewable energy resources, it is coming from the solar type of power plant. Okay, so by using the solar PV cells, by installing the solar PV cells, we can achieve the large number of the electricity. We can generate the large amount of electricity. Precisely, we are generating now at this particular date. We are generating 66.780 or 66,780 megawatt of electricity, which is around 16% of the total electricity generated in India. So largely in renewables also, most of the part of the energy is generated through the solar energy. So we are concentrating on this one, and we are also planting or planning the more and more solar PV cells or the power plants where we generate the electricity by using the solar radiation. So the potential is very high in India because generally, if you saw the location of India, it is uh, near to the equator. And if you saw all over the annually radiation data, the most of the radiation, solar radiation, which is received by each and every location, is much more than the average annual radiation of the global. Okay, so that's why the potential is very high. So we have to capture that energy. We have to capture the solar radiation, and that's why you will see in this particular renewable energy resources, the largest share is of solar energy share. Okay, it is around 16.1%, when you will compare it to the other resources. So based upon that, you can see there are different power plants has been already installed. The rooftop type of power plants are also uh, installed in many industries or in many enterprises, etc. So this is the actual condition of the solar energy. You can also see the generation capacity here, the install capacity. If you saw here, you will see the install capacity in India. So by using, you can view this particular the report, and you will find out the install capacity based on or sector-wise, region-wise, etc. Uh, you can see here the thermal mode, the amount of energy generated. Here the renewables are there, amount of energy generated. So from in the northern region, region-wise and also sector-wise. Okay. Generally, in the northern region, the solar energy generation is much less than the southern region, because southern region receives more radiation whenever we compare it to the northern region. Okay, so this particular the data you also you can refer to understand the position of the solar power sector in the Indian power sector. Okay, so this is the detail regarding that one. You can also see the state-wise and also the sector-wise variation or the data of the power generation uh, in this particular report. Okay, so in India there is large potential to achieve that particular or to capture the solar energy, because in India annually we are receiving average more solar radiation than the average global average of the solar radiation. So the next we can see the radiation spectrum. You already studied this one in heat transfer. So radiation spectrum means what? Whatever the radiation which is coming out from any one particular body, or the radiation which is emitted by one particular body, the wavelength range of that particular radiation is known as the radiation spectrum. If you saw or if you consider one particular light, any light, the radiation spectrum is what? It is the range of its wavelength. Okay, so you can see here, light is consist light is, we are considering as one type of wave. Okay, and it is having different wavelength. Okay, each type of light is having different wavelength. So you can see generally this light wavelength is vary from 100 kilometer wavelength to the 10 raised to minus 6 nanometer. Okay, so it is also, we can divide based upon the wavelength, we can divide based upon the frequency. So particularly in the radiation spectrum, we are considering taking wavelength as a characteristic, and we are dividing that particular electromagnetic wave based upon the wavelength. Okay, so you can see the gamma rays, it will contain the gamma rays, X-rays, ultraviolet rays, and the visible light band, infrared rays, microwaves, radio waves, etc. Okay. Now, based upon the wavelength of that particular light, we can classify that one, or the characteristics are depends upon the wavelength of that particular light. Okay. Now you can see this gamma rays, X-rays, and ultraviolet rays, which is having low wavelength, right? So you can see here up to 100 nanometer, you will see the ultraviolet rays are there. Now, these particular lights or these particular wavelength or the radiation having very less wavelength. Okay. So now wavelength you already know, that is the length between or length of the one sinusoidal wave, right? So these gamma rays, X-rays, and ultraviolet rays radiation is having very low wavelength. Okay, because it is having very low wavelength, it is contain very high energy in it. Okay, so it will contain very high energy. So whenever these type of rays or the radiation are incident on the human tissue, it will penetrate to the human body. Okay, because it will contain very high amount of energy. So when it passes or whenever it passes through the human body, it will negatively impact the human body. Sometimes you will say the ultraviolet rays are dangerous to the human body. Similarly, the extra dose of X-rays are also very dangerous to the human body, because these low wavelength radiation will contain very high energy. Okay, so that's why those are very dangerous to the human body, or those are very dangerous to the other plants and etc. Now, after ultraviolet rays and the infrared rays, you will see there is a visible light band. Whatever the light we are seeing to the naked eye, it is in this particular band. Okay, the wavelength of that light, it is in this particular band. So if you saw, the wavelength is varying from 100 nanometers to the 1 micrometer. Okay, uh, so you will see different colors will having different type of different wavelength. It is having different wavelength. It will having different frequencies. So the violet will have minimum wavelength in the visible light band, and the red color will have the maximum wavelength in the visible light band. Okay. After light band, you will see there are infrared radiation, microwaves are there, radio waves are there. These all radiation is called as a long wave radiation. Long wave radiation because its wavelength is high. Okay, it is in the centimeter or kilometer, etc. Radio waves having the largest wavelength. Okay, it is vary from 10 centimeters to the 100 kilometers. So you will understand the difference between the wavelength. Okay, and generally this difference or these wavelength characteristics or the properties used to classify the radiation spectrum. So whenever we considering all these spectrum or all these wavelengths, it is called as a radiation spectrum. Okay, so generally light is just an electromagnetic wave, okay, which is having different wavelength. When its wavelength is changing, its name or its characteristics or its properties are going to be changed, and based upon properties, we can classify that rays or that particular electromagnetic wave in the different types of the band. Okay, now these microwaves, radio waves, or infrared waves, which having higher wavelength. So it having higher wavelength, so that's why the energy contained in this particular radiation, infrared radiation, microwaves, and radio waves are less compared to the X-rays and gamma rays. Okay, so that's why these infrared rays, microwaves, radio waves are not dangerous to the human body or plant or any other uh, organism. Okay, so that's why you will see there are a tremendous amount of different applications of radio waves are there, microwaves are there, infrared waves are there. Okay, so these are the also called as a non-ionizing type of radiation. You already studied that in heat transfer. So this is called as a radiation spectrum. Now from this, the particular object, the particular radiation emitted by that particular object, it is depends upon its temperature. Okay, means consider there is one object. Okay, and you know the properties of any particular object. You already studied that one in radiation part, where if we kept one particular body at a particular temperature, the radiation coming out from that body, it is depends upon the temperature of that particular body. Means consider there is a one object which is at room temperature. Consider it is a 25 degree centigrade. At the room temperature also, it will emitted some amount of radiation. Okay, it may be a microwave, it may be a ultraviolet, it may be infrared, it may be visible, or it may be radio. But at room temperature also, it is emitting the some amount of radiation, even at 0 degree centigrade. Okay, even at 0 degree centigrade, it will emitting some amount of radiation. Okay, so any particular body which is having some temperature, it will going to emit the some amount of radiation. The main objective or the main constraint is that its temperature, the body of the temperature must be greater than absolute zero temperature. Now, absolute zero temperature is not 0 degree centigrade. Okay, absolute zero temperature means what? It is 0 Kelvin. And if you want to convert that into the degree centigrade, it is minus 273 degree centigrade. So if any particular body will achieve this temperature, there will be a zero radiation coming out from that body. So the principle of the radiation is that whenever any particular body which is having temperature more than absolute zero temperature, then it will always emit some amount of radiation. Okay. Now, in the case of sun, if you saw the average temperature of sun, it is around 5000 degrees centigrade. Okay, average temperature of the surface of sun, it is around 5000 degrees centigrade. So the amount of radiation emitted by that particular sun is directly proportional, or it is depends upon the temperature of that temperature of the sun. Okay, now at this particular temperature, sun will release or the emitted the radiation in this particular range. Okay, it will contain some part of ultraviolet, rays, whole visible band, and some part of infrared rays. Okay, so sun will release maximum amount of radiation in this particular band. Okay, it will contain some visible light, it will contain some ultraviolet light, ultraviolet radiation, and it will contain some part of visible light. Okay, the so maximum amount of radiation emitted by the sun, it is in this particular band. Okay, the sun also radiates the radiation in the form of X-rays, in the form of gamma rays, or in the form of microwaves, etc. Okay, but the amount of these rays or the radiation is very less compared to the other types of the radiation. Okay, so if you saw the radiation coming out or emitted by the sun, which is generally considered as a thermal radiation, it is in this particular band. It will contain the visible band. It will contain some part of infrared, and it will contain some part of ultraviolet rays. Okay. Now these radiation coming out from the sun, it will going to received by the earth or the earth surface, and that radiation is used for the other applications, to generation of electricity, for the heating purpose, etc. Okay. So we are going to see the solar radiation spectrum. You will see this is known as the solar radiation spectrum. So it will contain it is a wavelength versus the amount of radiation coming out at that particular wavelength. You will see the radiation spectrum of solar, or the maximum radiation which would emitted by the solar, it is contained from 0.3 to 3 micrometer. Okay, so it is in the range of 0.3 to 3 micrometer. Okay, so maximum amount of radiation emitted by the sun, it is in this particular range. Okay, this is the wavelength of that particular radiation. Okay, and you will see near about 0.32 or something, you will see there is a peak or maximum amount of radiation which is in this particular range or at that particular wavelength. Okay, and if you saw the visible range, it is in between 0.4 to 0.7 micrometer. So the nearly 43% of the radiation which is emitted by the sun, it is in the visible region. The 52% of the radiation which is in the infrared region, and nearly 5% of radiation emitted by the sun, it is in the ultraviolet region. So maximum amount of energy or the radiation emitted by the sun, which is in this particular two types, or the visible region and infrared region. Okay, the now this particular wavelength or this particular band, we can compare it to the thermal radiation band. If we saw the thermal radiation band, it is in the, it will included with some part of ultraviolet, a whole part of the visible band, and some whole part of infrared region. So this is also called as a thermal radiation. So maximum amount of radiation which is emitted by the sun, which is in the thermal radiation, which is also called as a thermal radiation. Now, this particular radiation, or this particular graph, or the variation of wavelength of radiation emitted by the solar, it is known as the solar spectrum, or the solar radiation spectrum. Okay, so this is called as solar radiation spectrum. The area under this particular spectrum, or the under this particular graph, it is known as the solar constant. Okay, it is known as the solar constant, or its value is near about 1367 watt per meter square. Okay, which is also known as the solar constant. So this is the solar radiation spectrum. uh, Solar radiation spectrum, and whatever the energy received by the earth surface, which is in this particular form or quantity. So this is regarding the solar radiation spectrum, then the solar simple radiation spectrum, and also the status of, or the, we can say, the potential of solar energy in India. Okay, so we will stop here. The remaining points we will going to cover in next coming lectures, in which the most important is geometry of the Earth and Sun. Okay, related to the radiation, and the different terms related to that particular geometry, because the amount of radiation is depends upon various factors like the location, then the incident angle of radiation, then the season, which season is that, then the distance between the equator to that particular location. So it is depends upon various factors, and the terms which are used in generally used in the study of the solar radiation or the solar energy, that we are going to cover in the next section. Okay.